Hello everyone, good morning, good evening, good afternoon, wherever you are in the world. My name is Dennis and welcome to the channel Math with Dennis, and we are continuing with our series Unit 1, Chapter 1, this is Lesson 3, 9709. That's the paper code and AS level maths. We are following the Cambridge curriculum, and this is the AS level, or some call it Tier 12, and we are continuing studying the first chapter in the course book, Quadratics. In the first video, we looked at factorization and some of the exam questions and how factorization can be applied to different situations, mathematical situations, and we also saw some past paper questions. In the second video, we looked at completing squares in a sense of AS level maths, and now today we are going to look at quadratic formula. How is the quadratic formula used? How is it derived? And today's learning objective, we are going to learn the quadratic formula. We are going to see how it is derived and where it comes from. And at IGCSE, you've been using the quadratic formula, but you may not know how it comes about. So today we're going to learn how it comes about, and then we are going to also learn the different parts, the major part of the quadratic formula that you can use to determine whether the roots of a given quadratic are, number one, the same. Sometimes they call it equal roots. Number two, are the roots different? Okay, and number three, is this quadratic having roots? Actually, some quadratics don't have roots. Okay, so we are going to look at that part, and we are going to get a new term. You will also learn a new term, a new word under quadratic formula called the discriminant. So learning objectives are quite a number. Number one, learn how to derive the quadratic formula. Number two, learn which part of the quadratic formula can help someone determine whether the equation has equal roots, whether it has different roots, or it does not have any roots. Remember, the word roots means the solution to the quadratic. Okay, and then number three, we are going to learn how to derive actually the quadratic formula. Basically, the learning objectives are all moving around the quadratic formula. Yeah. Okay, so let's begin. So I'm sure you have looked at quadratic formula before and it's all good. We're just going to build on what you already know. Okay, so as we said in the previous classes, and by the way, in my previous video, I would like to correct something to clarify the paper code that I mentioned towards the end of my last video under completing squares. It's supposed to be 9709, not 9702. 9702 is a different course, So Math AS and A-level Math Cambridge curriculum, the paper code is 9709. Thank you. All right, so this is the general form. This is the general form of any quadratic equation. So the general form is always ax squared plus bx plus c equals 0. So when you see an equation arranged in this form, it is quadratic. So now we are going to derive. We are going to derive the quadratic formula but before we derive it, we need to know how it looks like. Maybe when I say quadratic formula, many don't know what I'm talking about. This is the quadratic formula. I'll write it here. X equals negative b plus or minus under root b squared minus 4ac all over 2a. So this here is the quadratic formula, which we are going to derive from the general quadratic equation. So step 1 is to divide all through by the coefficient of x squared. So once we divide throughout, now we get a new result, and this is the new result, plus c out of a equals 0, because a 0 divided by any number is 0. Now at this stage we are going to complete squares. We talked about completing squares in the previous video. So we complete the square. Remember, you halve the coefficient of x. So this is the coefficient of x. Halving means multiply it by half and then square the results. Okay, so after that, this part, because it crosses the equal sign, it becomes a negative, but then we add the halved part, the part that we multiplied by a half, we add and square. Like exactly what's on the left is what we add to the right. This is a bracket, don't get confused. Okay, so let's simplify this a bit. So this is plus b over 2a, and it is all squared, and this is negative c over a plus b over 2a whole square. Okay, I hope we are all together at this stage. So now the next step, this is what we did under completing squares, if you notice. So now we have x squared plus, I beg your pardon, now we can take out the, I think I should change the color. Now we are going to take out the squared and do this all squared, because both of them are power 2, so we can put them under one block, under one bracket, and we square it. Okay, and then we can bring the items on the left, I mean on the right of the equal sign to this side. So this would be, after squaring this, it would be b squared over 4a squared. Okay, and it would be a minus, and then the c will be, c out of a will be a plus, and now we equate it to 0. Hope that makes sense. Okay, alternatively we can maintain it on the other side of the equal sign. I think that's easier. Let's maintain it. So now we have equals, now this side we can write the positive part first, b squared over 4a squared minus c out of a. Hope that makes sense, but this color is not so good. Sorry. So now we are going to continue simplifying. So x plus b out of 2a whole square equals, now here the common denominator, the LCM, common multiple, sorry, would be 4a squared, and now we are solving these two, like we are simplifying them. All right, so basically here we shall get b squared minus 4ac. Okay, this is the simplified part. All right, now we have this, so let's continue. After that, we are now going to write x plus b over 2a whole square equals, I'm just repeating this part, 4ac over 4a squared. Okay, so in order to get rid of this power 2, we have to square root on both sides like this. So this power 2 cancels with that root, and now let's see if green works. Okay, now we have x plus b over 2a without a power 2 now, and then this side, the square root sign, the radical, the root sign, is on both the numerator and the denominator. But the denominator, the square root of 4a squared is 2a. So we shall now maintain it at the with the numerator, like b squared minus 4ac all over 2a, because now down here we've got the square root as 2a. Okay, so now we shall say x equals, if we take this b over 2a, the other side it will be negative. Okay, but because this is a square root, and the square root of a quadratic, remember I said the quadratic has two roots, two answers, two values of that unknown because of the power 2. So we can introduce the plus or minus to represent the two values, and then we have b squared minus 4ac all over 2a. Now because these 2a are both a common denominator, so they will have the common LCM, and now we shall have negative b plus or minus root b squared minus 4ac, and then the common LCM, which is 2a. Now this here is the quadratic formula, and what I've been explaining are the steps on how to derive the quadratic formula. Does that make sense? If you have any questions, please comment. I will respond. And this is the quadratic formula. We have derived it. It comes from the general form of the quadratic equation. Okay? Yes. So our learning objective number 1, derive the quadratic formula. This is the quadratic formula. But the good news is this formula will always be provided to you in the formula booklet. Okay? You will always you will see it in the formula booklet. Okay, so if you need to use it, you can just check the formula booklet. This exam, they will always give you a formula booklet. Yes, so 9709 is the code, the math paper, pure 1 mathematics. You'll always be given a formula booklet, and this formula will always be there, but it is part of the lesson that you learn how to derive it. In other words, we are making x the subject of the equation ax squared plus bx plus c equals 0, and we have made the equation. Now the next step is we are going to learn how to use it, to solve a quadratic equation. Okay, so this is part of what we've done, so no worries, I've not skipped any question. Okay, so this is an example of how I'm going to explain how to use it, how to use the equation. So let's start. Okay, so you can see that this is exactly in the form ax squared plus bx plus c equals 0. So this is a quadratic. So a in this case is 7 because it is the coefficient. Actually, it is better if we write it here to make much more sense. Ax squared minus bx minus c equals 0. So a is 7. B is 4. You can see it 4. No. B is, okay, we take it literally as it looks like. I'll explain this. So it's negative 4, and then C is negative 12. Okay, you take the figures, you take the coefficients the way they are in the equation. No worries about that. Then you can check the formula booklet to write out the quadratic formula. Negative b plus or minus root b squared minus 4ac all over 2a. Now the next step is to substitute. So b, there is a negative for the formula, but b is negative 4. okay, then plus or minus root negative 4 all square minus 4 times a, which is 7, and then times c, which is negative 12. You take the coefficients the way they are over 2 times 7. Now we always think about using brackets, okay? So negative and negative, I think this will be okay. Negative and negative, yes, it will be positive, so 4 becomes a positive. Then this, any negative number squared, we get a positive, so this gives us 16. Now some students make a mistake here of doing this, negative 4 squared, and once you put this in a calculator, it will give you negative 16, which is not correct. So always use the parentheses, okay? Always use the parentheses. It is important that you remember a negative squared is always positive. Okay, so here now I'll check on my calculator to avoid mistakes. Okay, so 4 times 7 is 28, and then times 12, and then here we shall get negative, because you can see in the parenthesis we have 4 times 7 times negative 12, so negative 336, okay, and then all over 14. You have to be careful here, and then here we continue our simplifying. Now we have 4 plus or minus root 16. Because we have two negatives, it will be now plus 336 over 14. Okay, now the first value of x, we write 4, we take one of the signs, we can take a plus, and then you can put this in a calculator. 16 plus 336, we get 352. Okay, so 352 over 14. Now you can entirely use a calculator to get the answer for this, and this will be our first value of x. I'll leave you to that. And then the second value of x, we take the minus, because here we have two signs, plus and minus. Now this will be the same values, 352, root 352 over 14, you get the second value. So basically this is how we use the quadratic formula. And now we talked about a part of the quadratic formula that is used to determine whether the quadratic has roots, and the roots are equal, the roots are different, or it has no roots. Now the quadratic formula, remember, is negative b plus or minus root b squared minus 4ac over 2a. Now this is the quadratic formula, but this part here that I'm highlighting has a name. So b squared minus 4ac is called a discriminant. So I hope this is the spelling. Discriminant, I think this is an E, I'm not sure. So discriminant is this part. So if you find that the coefficient of x, b squared, is equal to 4ac, then it implies that the quadratic has equal roots. When I say equal roots, it means the same values. x1 will be the same value as x2. Okay, and if b squared is greater than 4ac, then this implies unequal, okay, or different roots. Remember, the word roots means the values of x. And if b squared is less than 4ac, it will imply that there are no roots, because there's no root of a negative number, so no roots. Okay, At the end of quadratics, I'll get more past paper questions, and then I'll show you how to apply some of these rules when we are solving equations. So basically, you can take these notes and you can look up for 9709 past papers, CIE past papers, and you can find some quadratic equations, practice on how to use the quadratic formula to obtain the roots of the quadratic formula, practice on how to derive the quadratic formula. It helps you practice using completing squares, and also learn what the discriminant tells you about a particular quadratic formula. I hope this session is beneficial and understandable, and I hope you enjoyed these 20 minutes. And the paper code is 9709. Currently I'm running a crash course on Cambridge Pure 1 Mathematics for AS level, and this is chapter 1 and this is lesson 3 about quadratics, and we are continuing with the next one. Our next one will be solving simultaneous equations, whereby one equation will be a linear equation and the other will be a quadratic. How do we go about that? So that will be in the next video. Make sure you subscribe, make sure you share, and make sure you hit the notification bell. So I'll see you in the next video. I hope you enjoyed. My name is Dennis and this is the channel Maths with Dennis. See you and have a nice time. Bye bye.